For this video, we will learn the process of integration. So integration is the process of finding the antiderivative from our previous discussion. I've told you that integration or integral calculus is just the opposite of differential calculus. If for differential calculus, to analyze the whole, we divide it into small parts and analyze those small parts. Integration, we are taking the small parts and forming it or adding it up together to form the whole. So for example, we have here a function of x is equal to the integral of f of x dx. You can say that this is the integral sign. The small f of x is our integrand. Capital F of x is our integral or the antiderivative. And we have your dx is the differential of x. From differential calculus, we were looking for derivatives, and derivatives is talking about the change in a variable with respect to the change of another variable. Differential is just taking into consideration the change in that specific variable in a variable. For example, in y prime, this is equal to dy over dx. That is the change in y with respect to the change in x. Your dy is the differential of y, and your dx is the differential of x. Change in y, this is the change in x. That is your differential. So for example, going back to the process of integration, we have here a function f of x. F as a function of x is equal to 5x raised to 4. If you will take the antiderivative, there are many possible answers. That would be the integral is equal to x raised to 5. Because if you take the derivative of this one, you will arrive with the integrand. For example, if you take the derivative of this one, first derivative, this is 5x raised to 4. Second possible answer would be x raised to 5 plus 3. If you take the first derivative of this function, this would be 5x raised to 4 plus 0. Same with the first example, or the first possible answer. Okay? And it can also be f of x equal to x raised to 5 minus 31. If you take the first derivative, you will still arrive with 5x raised to 4 plus 0 or minus 0. So basically, in general form, we can say that the integral is equal to x raised to 5 plus a constant. There are many possible values for that constant. So this is what we call our general function. And the constant here is what we call our constant of integration. So let's now continue with the discussion on the indefinite integral. So for the indefinite integral, the simplest property would be the constant of integration is always present. So we can say that the integral of f of x dx is the indefinite integral of capital F of x. So what are the basic properties of the indefinite integral? Number 1, the integral of du is equal to u plus the constant of integration. Second property, integral of du plus dv minus dw is just equal to the integral of du plus the integral of dv minus the integral of dw plus the constant of integration. So the third would be the integral of a constant times du is equal to c integral of du plus c sub 1. So basically we are just factoring out the constant that is beside du. So those are your basic properties of an indefinite integral. Let's now move to the general power formula. So the general power formula states that, let's have different color for that one. Let me use this one. Okay, that would be the integral of function u raised to an exponent n. Your n here is a constant, du. This is equal to u raised to n plus 1 divided by n plus 1 plus the constant of integration. This formula is only applicable if, let me use another color for you to be familiarized with it. Take note, for you to use this formula, your n should not be equal to -1. This would be having another formula. In the meantime, let us just memorize this one, and let's have some examples in the application of this general power formula. So for our examples, number 1, we have the integral of 6x raised to 3 dx. For this one, we will go back to the properties of the indefinite integral. If you have a constant beside your function, you just factor it out. So this can be written as 6 integral of x raised to 3 dx. Okay, now let us solve. This is 6. Applying the general power formula, that would be u, or let us first define our u. Your u here is equal to x. Your n is equal to 3. And your du, or the derivative of x, is, or the derivative of u, based on this one, you will take it from here. Derivative of u is equal to the derivative of x. If you will go back to this portion, you have u, it follows the formula, constant integral of u raised to n du. So we can apply the formula because it follows the form of the equation, follows the form of your formula. So we can apply it. Copy that constant 6 and apply the formula. This would be u is x raised to n plus 1. Your n is 3 plus 1 divided by 3 plus 1, and your constant of integration. So if you will solve for this one, 6 times x raised to 4 divided by 4 plus c. Distributing 6, you will have 6 over 4 x raised to 4 plus 6 times the constant of integration. 6 over 4 can also be written as 3 over 2 x raised to 4, but 6 times the constant of integration will still be a constant, right? So we can just say that that is equal to a constant of integration to simplify things, or c sub 1, to distinguish it from the original constant of integration. So this is your answer using the general power formula. Now let's try to have another example. Number 2. The integral of 6 dz over z raised to 4. So how are you going to do this? Remember that you can write this as 6 z raised to negative 4. If you will place this function on the numerator, you will just change the sign of your exponent, d sub c, integral. And just like the previous example, you factor out the constant. This would be z raised to negative 4 d sub z. Your u is equal to z. Derivative of u is equal to d z. And your n, or the exponent, is equal to negative 4. Now, can you use the formula? Since its exponent is negative 4, the answer would be yes, because our condition says only that if n is equal to negative 1, we cannot use this formula. But in this case, the exponent is equal to negative 4. So, obviously, we can use the formula. This is equal to 6 u raised to n plus 1, where n is negative 4, plus 1, divided by n plus 1, negative 4 plus 1, plus c. So, simplifying, we have 6. Let us continue this one. This is z raised to negative 3 over negative 3 plus c. Simplifying, you will have 6 over 3, remember the negative, z raised to negative 3 plus 6c. Similar to the previous example, this can be written as negative 2. Negative 6 divided by 3 is negative 2. And we can put it in the denominator, and then change the sign of the exponent to positive, retaining the value of your exponent. This is still plus c. You have your answer using the general power formula. We can try to check using differentiation. If we try to check, let's try to check our answer. So, this can also be written. This is equal to f of x. The integral is equal to negative 2 z raised to negative 3 plus c. If you will try to find the derivative of that function, that will be negative 2, bring down the exponent, negative 3, copy the base, exponent negative 3 minus 1, plus the derivative of a constant is equal to 0. So this will be equal to 6 z raised to negative 4, or that can also be written as 6 over should have a differential because we are looking for the differential, not the derivative, plus c. This is 6 over z raised to 4. This the differential of z. And if you will notice, you arrive with your given, which is 6 dz over z4. And in that case, our answer is correct. That is how you check whether your answer in finding the indefinite integral is correct or wrong. So let's have our last example using the same process. Number 3. The integral of differential of x over 2x minus 7 raised to 4. So we can write this as the integral of 2x minus 7 raised to negative 4 dx. So if you will try to dissect the problem, your u here, or the base, is equal to 2x minus 7. And the derivative of u is equal to this from this one, or the differential of u rather, it should be, copy the constant coefficient and multiply it by the derivative or the differential of x. The differential of a constant is equal to 0. Or let's carry the sign, that should be negative 0 or 2 dx. And then we will have your n is equal to negative 4. That is not equal to negative 1. So we can apply the general power formula. So if you will go back to our equation, we have our u raised to n, but the differential of our base u or du is not equal to 2 dx. So what we will do for us to use the formula, we will introduce, just copy u raised to n and introduce 2 dx. So this is u raised to n du. But if you change the equation on this part, you are changing the sense of your equation. So for it to be still having the same sense, we will introduce a balancing factor on this part of our equation, 1/2, such that if you will factor this out to the other side of your integral sign, that would be 2 divided by 2 or 1, you are still going back to the original value of your problem. We are not changing its value, but we are just changing its form for us to use the power formula. So now that we have transformed it, we can solve for the integral of these functions. So 1/2, this would be u raised to n du. We can write 2x minus 7 or u raised to n plus 1 divided by n plus 1, 4 plus 1, negative 4 plus 1, and of course the constant of integration, c. This can be written as 1/2 2x minus 7 this is raised to negative 3 divided by negative 4 plus 1 is negative 3 plus c. Further simplifying, we will have distribute 1/2. This would be negative 1 over 6 times 2x minus 7 raised to negative 3 plus 1/2 of c, or this can be written as c sub 1, negative 1 over 6 2x minus 7 raised to 3 plus c sub 1. So to check whether our answer is correct, let us try to find the derivative of this, of our answer. We can write this as negative 1 over 6 2x minus 7 is to negative 3 plus c sub 1. So for the first derivative, this would be negative 1 over 6, bring down the exponent, negative 3, copy the base, 2x minus 7 raised to n minus 1, and multiplied by the derivative of our base, or the differential of our base. Basis would be 2 dx minus 0 plus the derivative of a constant, or the differential of a constant, is 0. So if you simplify, this would be negative times negative is positive. 3 over 6 can be written as 1/2. 2x minus 7. Negative 3 minus 1 is negative 4 times 2 dx plus 0, or we can just remove this one. So 1/2 times 2 is 1, so they will cancel to 1, and then this would be dx divided by 2x minus 7 raised to positive 4. She will check. That is our given. So our answer is correct. So that is how you find the integrals, or the indefinite integrals of functions. Using the general power formula. So let's have another equation, another formula. This is the integral of a logarithmic function. So the formula would be the square root of du over u du over u is equal to the natural logarithm, or ln, of u plus c. If you will notice, this is, we can write du over u as u raised to negative 1 du. Right? Or let me rewrite that one. Du over u can be written as u raised to negative 1 du. From our general power formula, recalling it, we have the integral of u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c. And we have a condition that n, or the exponent, should not be equal to negative 1, because if that is equal to negative 1, negative 1 plus 1 will be 0 here, and that would be an undefined answer. So for this one, for our integral of logarithmic functions, it follows this form, wherein the exponent is equal to negative 1. So if that is the exponent is equal to negative 1, we can use this formula, or the general, or the integral of a logarithmic function formula. So let's have an example for that one. This would be number 1, the integral of x squared dx over x cubed plus 4. So our u here is equal to x cubed plus 4 du is equal to 3x squared dx, and we can write this into the integral of x cubed plus 4 raised to negative 1 x squared dx. So we can apply the power, the integral rather, of a logarithmic function, because it follows that form, du over u. But then let us first introduce the constant 3 for us to apply the formula. Integral of du is x squared 3x squared dx over x cubed plus 4, and the balancing factor would be 1/3, because you added a factor of 3 on this part of your equation. So this would be 1/3 of the formula that we have. This is du over u. Formula is ln of u plus c. So this would be the natural logarithm of u. Your u here is x raised to 3 plus 4. Don't forget to put the parentheses to indicate that this group is your u, plus the constant of integration c, because we are dealing with the indefinite integral. So simplifying, distribute 1/3. This would be 1/3 ln of x cubed plus 4. 1/3 times c is just equal to a constant. So this is our answer. Another example. This is the last one for the logarithmic function integral. Would be y minus 3 dy, get the integral sign, divided by y squared minus 6y plus 1. So let's try whether it will satisfy the form of our formula. This would be u, y squared minus 6y plus 1. Try to find du. One clue here is that the highest exponent at your denominator should be more than the exponent of your numerator, or the highest exponent at the denominator is greater than 1 as compared with the exponent of your numerator. And you can always check for you to be able to verify whether you can apply the formula or not. So this would be 2y minus 6. So at first glance, it does not this is dy, because we are talking about differential. 6 dy. And you can factor out dy. And then factor out 2. 2 times y. If you factor out 2 in negative 6, that would be negative 3 dy. And if you will go back, you are lacking a value of 2 in your numerator for you to apply the formula. But don't worry, because you can always use a balancing factor. So let's continue. The integral of 2y minus 3 dy divided by y squared minus 6y plus 1. Don't forget your balancing factor, 1/2. This is du. For your integral, we can use the logarithmic function formula. This is 1/2 for the constant balancing factor, and this is your u, this is your du. You can apply the formula. That is just the ln, or the natural logarithm of your u, which is y squared minus 6y plus 1. Don't forget the parenthesis, plus the constant of integration. This would be 1/2 ln of y squared minus 6y plus 1, plus of course the constant of integration. 1/2 times c is still a constant. So that is our answer for number 2. In the next videos, we are going to discuss about the concept of the definite integral, because this is we will discuss the definite integral, because we just covered here the indefinite integral. And remember that the indefinite integral always have a constant of integration. For the definite integral, there is no constant of integration, and we will find out how does that happen on our next video. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button, and I'll see you on the coming videos. Thank you.